Hello student, in previous lecture we discussed the outline of syllabus of our paper, that is CH302 Inorganic and Organic Chemistry. Now in this lecture we are start with the introduction to coordination chemistry. In that we are going to discuss the basic terms related to coordination chemistry. Coordination chemistry is the study of compound formed between metal ion or negatively charged molecules, and the compound form is called as a coordination compound. In that, this is a coordination compound entities. In that, cobalt is a central metal atom. There are 6 ammonia molecules are attached to the central metal atom. Ammonia is ligand. In square bracket, the central metal ion along with their ligands are present. This square bracket is known as a coordination sphere, and the charge of the complex is +3. So, these all terms we discuss in detail one by one. First, we are start with the central metal ion. Central metal ion the cation to which one or more negative or neutral ion are coordinated is known as central metal ion. Central metal ion. In this coordination compound entities, cobalt is a central metal atom. Now, what is meant by ligand? Ligand is an electron-rich species having tendency to donate electron to the central metal ion. Is known as ligand. So here, ammonia is a ligand. It can donate lone pair to the central metal ion. Now, what is meant by coordination sphere? The central ion together with molecules are ion coordinated to its constitute is known as coordination sphere. So coordination sphere is nothing but the square bracket here indicated. In that, the central metal atom along with their ligands are present. Now, what is meant by the charge of the complex? Charge on the complex is the charge carried by complex ion is the algebraic sum of So charge carried by central ion and ligand coordinated to it, So here the charge on the complex is a +3. Now what is meant by the coordinate bond? Coordinate bond. Coordinate bond is the bond formed by unequal sharing of electron pair by two atoms and this electron are shared by one and same atom, This is known as a coordinate bond. Here the bond formed between central metal atom and ligand is a coordinate bond. So these are the terms related with this coordination compound entities. Now let's discuss what is meant by what are the types of ligand. So depending upon the density of ligand, the types of ligand are occur. So first type, that is monodentate ligand. Monodentate ligand is nothing but the ligand have a tendency to donate electron to the central metal ion through only one atom and form only one coordinate bond. Is known as monodentate ligand. And the example of this monodentate ligand is a ammonia molecule. As we know that the ammonia have a one lone pair, so it can donate this lone pair to the metal atom. So that's why ammonia is a monodentate ligand. Then second, bidentate ligand. The ligand have a tendency to donate electron central metal ion through two atoms and form two coordinate bond. Two coordinate bonds are known as bidentate ligand. Bidentate ligand. And the example of this bidentate ligand is a ethylene diamine. As we know that the ethylene diamine has two amine groups. It can donate by this two amine group to the metal atom, or we can write like that. These lone pairs can donate the electron to the metal atom. So the example of bidentate ligand is a ethylene diamine. Now what is meant by the tridentate ligand? Third type, tridentate ligand. The ligand have a tendency to donate electron to the central metal ion by three donor atoms and form three coordinate bond are known as tridentate ligand. And the example of this tridentate ligand is a triethylene diamine. Triethylene diamine can donate through three nitrogen atoms lone pair. So the example is triethylene diamine. Here so this is a central metal atom and so this is an example of diethylene triamine, tridentate ligand. Now what is meant by the polydentate ligand? Fourth number, that is a polydentate ligand. Polydentate ligand is ligands which have donate. The ligand which has tendency which have a tendency to donate electron through 2 or more than 2. More than 2 donor site or atoms and form 2 or more than 2 coordinate bond with central metal atom is known as polydentate ligand. And the example of this polydentate ligand is a very famous one, that is EDTA, ethylene diamine tetraacetic acid, EDTA. So here EDTA can donate electron approximately 6 donor atoms so it can donate electron by these 4 oxygen and 2 nitrogen atoms. So there are total 6 donor site or donor atoms in EDTA. So EDTA is a polydentate ligand. Now let's discuss what is meant by the coordination number. Coordination number is nothing but number of ligand attached to central metal atom. So coordination number is a total number of ligand attached to or coordinated to central metal ion. Is known as coordination number. Coordination number of that central metal ion. So let's discuss the various coordination number with respect to their metal ions. So here coordination number and metal ions. So So we know that there are 2, 4, 6 and 8. So generally these coordination number are generally found. So the example of two coordination number, that is silver plus, when there is a 4 coordination number and the metal ions are platinum plus 2, zinc plus 2. When there is a 6 coordination number, the metal ions may be and when there is a coordination number 8, the metal ions may be molybdenum in plus 3 oxidation state. So these are the coordination number with respect to their metal ions. Now, if suppose the complex ion, if you take an example of that complex ion, that is a nickel, hexaquanickel ion 2 plus. In that, the nickel have a 6 coordination number, means that there are total number of ligand. Here is a water molecule is a ligand and the total number of water molecule is a 6. So that's why the coordination number of nickel is a 6. So these are the coordination number. Now let's discuss what is meant by the chelating agent, chelate and chelation. So first we have to discuss what is meant by the chelating agent. Chelating agent is nothing but when a bidentate or polydentate ligand is attached to same central metal ion again 1 minute to two or more than 2 donor site to the same central metal ion forming a ring structure The ligand is known as a chelating ligand. And the example of this chelating ligand, that is ethylene diamine, as we taken an example as ethylene diamine is a chelating ligand. It can bind through central ion to the 2 donor site here. This is an example of chelating agent, ethylene diamine. Now, what is meant by chelate? Chelate is nothing but, and the resulting complex, when there is a formation of chelate complex and the resulting complex is known as a is known as chelating. What is meant by chelation? So chelation is nothing but the process of formation of chelation between metal ion and chelating agent, is known as chelation. So this is a chelation. Now we have to discuss the example of the chelating agent. So from this example we can clearly differentiate the monodentate and bidentate or the chelating agent. Suppose this barium is a metal ion. So there is a 4 monodentate ligand. This single A denotes the monodentate ligand, and if we form complex with this simple monodentate ligand, then so this is a simple complex. And if we take an example of bidentate ligand or chelating agent, the complex is as like this is a chelate complex or chelate. So from that we can easily conclude that if we use the simple monodentate ligand, there is a no chelate, and if we use the bidentate or more than bidentate ligand or the ligand which have more than 2 donor sites, it form a ring. So it is a chelate complex. From this example we can clearly illustrate that the bidentate or polydentate ligand form a ring structure. So what is meant by the chelate effect? Let's discuss what is meant by the chelate effect. Chelate effect is nothing but there is a formation of ring, as we know, and this ring is formed by chelating agent. So when a 5-member or 6-member ring is formed, is more stable than complexes has no ring, then complexes have a no ring. Why so? Is known as chelate effect. When a 5-member or 6-member ring is formed in complex is more stable than the complexes which doesn't have a ring. This is known as a Chilate effect. Due to Chilate effect, the entropy, because due to Chilate effect, entropy of the complex is increases, so that's why the stability is also increases. Stability, so stability is increases. So this is known as a Chilate effect. So we can conclude it that if there is a ring in the complex, this complex is more stable than the complex which doesn't have any ring. So the example of this complex, that is, if suppose hexamine, nickel, second ion, and triethylene diamine, nickel ion, if we compare this two example, we can easily conclude that the latter one, that is a triethylene diamine nickel ion, is more stable due to there is a ethylene diamine ligand. We know that the ethylene diamine is a bidentate ligand. It can form a ring structure. So that's why the triethylene diamine nickel ion is a more stable complex. So we will stop here. In next lecture, we are going to discuss the characteristics of chelating agent or chelation and the comparison between the chelating and metal complexes.